Hi everyone, welcome back to Vijay Academy. In the previous video, I have explained the exercise 2.2 from polynomials, first main question number 1 and 2. So in this video, I will be explaining exercise 2.2, first main question number 3, 4, 5 and 6. So in this we need to find the zeros of the polynomial and verify the relationship between zeros and the coefficients. So we have to factorize the given polynomial and find the zeros of the polynomial. For that, first we need to write the given polynomial in the standard form. So as we know that the standard form of the quadratic polynomial is ax square plus bx plus c. We need to write the exponents in the decreasing order. But here the exponents are not written in the decreasing order. So let us write 6x square in the first place and minus 7x in the second place and minus 3 in the third place, so that we get the decreasing order of the exponents, that is 2, 1 and 0. So this is the decreasing order of the exponents. So now after writing this in the standard form, let us factorize the given polynomial. So to factorize the given polynomial, first we need to split the middle term. To split the middle term, we need to write the sum and product. The sum is minus 7, that is the numerical coefficient of the x. So minus 7 is the sum. And the product is the product of numerical coefficient of x square, that is 6, and the constant minus 3. So 6 into minus 3 is minus 18. So the product is minus 18. And now let us identify the two numbers which will satisfy these two conditions. That is, by adding two numbers we should get minus 7, and by multiplying the same two numbers we should get minus 18. So now look at the sign of the product first. Always please look at the sign of the product. So the sign of the product is negative. So when we multiply two numbers we should get negative number. That means one number should be negative and one number should be positive. So from the product we came to know that one number should be negative and one number should be positive. Now when the sum is negative, and also here from the product we came to know that one number should be compulsorily negative and one number should be compulsorily positive. So as we know that when we add the greater number as negative greater number and positive smaller number, we always get negative number as the sum. So using this rule we can conclude that the greater number is negative and smaller number is positive. So greater number is negative and smaller number is positive. Now let us write all possibilities for minus 18 as the product. So for minus 18, the all possibilities are taking the greater number as negative and smaller number as positive. We can write minus 18 into 1. So greater number is negative, smaller number is positive. And the next possibility is minus 9 into 2. And one more, we have minus 6 into 3. So these are the three possibilities for getting minus 18, taking greater number as minus and smaller number as plus. Now these three pairs, all the three pairs will satisfy the condition minus 18, multiplication minus 18. Now which one of this will also satisfy the sum minus 7? So by adding minus 18 and 1 we get minus 17. So we cannot take the two numbers as minus 18 and plus 1. Now go to the second one, that is minus 9 and plus 2, which will give you minus 7. So this will satisfy, minus 9 and 2 will satisfy both the conditions, that is the product and sum. Now we can split the middle term using minus 9x and plus 2x. So equate the given polynomial to 0 because we are finding the zeros of the polynomial. So write the first term 6x square and the last term minus 3 as it is, and split the middle term as minus 9x and plus 2x. And now group them. So take the first two terms as one group and the last two terms as another group. Now from the first group we have to find the common factor. So the common factor from the first group is, so let us write the factorization of each term, that is 6x square. So factorization of 6x square is 2 into 3 into x into x, and the factorization of 9x is 3 into 3 into x. So from this we get 1 3 as common and 1 x as common. So we have 1 3 and 1 x as common, that is why we can take 3x as common factor. So from the first two terms 3x is the common factor. So divide both the terms by 3x and write the quotients inside the bracket. So dividing 6x square by 3x, we get 3 1s are 3 and 3 2s are 6. X square by x is x, so quotient is 2x. So write 2x here. Otherwise, from the first factorization, look at the 6x square equals to 2 into 3 into x into x. So from this, just leave the common factors 3x and take the remaining 2 into x, that will be the quotient. So next, from the second one, divide minus 9x by 3x. So 3 1s are 3 and 3 minus 3 is a minus 9. And now x and x will be divided, means will get cancelled. So we get the quotient minus 3. So we can write minus 3 here. So otherwise we can take the leftover number from the 9x factorization. So that is 3 along with the minus sign. So now from the second part, 2x and minus 3, there is no common factor. So other than 1, there is no common factor other than 1. So take plus 1 as common, and dividing 2x by 1 we get 2x, dividing minus 3 by 1 we get minus 3. Now from these two, from 3x into 2x minus 3, and from 1 into 2x minus 3, we have the common binomial, that is 2x minus 3. So write 2x minus 3 as a common binomial, and dividing the first term by 2x minus 3, we get 3x as the quotient, and dividing the second term, that is 1 into 2x minus 3 by 2x minus 3, we get plus 1 as the quotient. Now we equate each factor to 0 and find the zeros of the polynomial. Equating 2x minus 3 to 0, first transpose minus 3 to RHS, we get 2x equals to 3 and x equals to 3 by 2. So take this as alpha, 1 0 of the polynomial. And now we equate second factor, that is 3x plus 1 to 0, and now find the other 0. So transpose 1 to RHS, we get 3x equals to minus 1 and x equals to minus 1 by 3, so which is beta, the second 0 of the polynomial. Now let us move on to the verification of the relationship between the zeros and coefficients. So alpha is 3 by 2 and beta is minus 1 by 3. So alpha is 3 by 2 and beta is minus 1 by 3. Now let us note down the numerical coefficients of this polynomial. So 6x square minus 7x minus 3 is the standard form. So the numerical coefficients are a is 6, b is minus 7 and c is minus 3. Now let us take the first relation, that is alpha plus beta equals to minus b by a. Alpha is 3 by 2 and beta is minus 1 by 3. And minus of b value is minus 7. So minus of minus 7 divided by 6. So the LCM of 2 and 3 is 6. In the LHS, LCM of 2 and 3 is 6. Now multiply the first rational number by 3 by 3. 2 3s are 6, so 3 3s are 9. And multiply the second rational number by 2 by 2. So 2 3s are 6 and minus 1 into 2 is minus 2. So in the RHS, minus of minus 7 will become 7 by 6. In the LHS, 9 minus 2 is 7. So we get 7 by 6 and 7 by 6 on both sides. One relation is verified. The second relation is alpha into beta equals to c by a. So multiply both the zeros, that is 3 by 2 into minus 1 by 3, and c by a. C is minus 3 and a is 6. Now in the LHS, numerator into numerator, that is 3 into minus 1, which is minus 3, denominator into denominator, 2 into 3, 6. In the RHS, we are getting minus 3 by 6. So writing this in the standard form, we get minus 1 by 2 on each side. So hence both the relations are verified. So let's move on to the question number 4. So So in the question number 4, we have only two terms, that is 4u square plus 8u. Now from each one of them, we have the common factor. From this can be made into only one group. So take the common factor and divide each term and write the quotients inside the brackets. Now from 4u square and 8u, let us see, first let us write the factorization of each term. So 4u square can be written as 2 into u into u, and 8u can be written as 2 into 2 into u. So from this we have two 2's are common and one u is common. So finally we can take that 2 into 2 is 4, 4u is common factor. So taking 4u outside and divide each term by 4u. So dividing 4u square by 4u, we get 4 and 4 gets cancelled. U square by u will give you u. So u is the quotient for first term. And divide second term also by the common factor. U and u will get cancelled. 4 1s are, 4 2s are. So the quotient is 2. So we get the quotient as 2. Now we equate it to 0 since we are finding the zeros of the polynomial. Now we got two linear factors, so equate each factor to 0. So equating 4u to 0, we get u equals to 0 divided by 4, which is 0 itself, that is alpha. And then equate the second factor to 0, u plus 2 equals to 0, then transpose 2 to RHS, we get u equals to minus 2. This is the another 0 of the polynomial. Now we got the zeros of the polynomial. Let us verify the relation. So alpha is 0 and beta is minus 2. Now write this in the standard form. When you write this in the standard form, we get 4u square plus 8u, and there is no constant, write it as 0. Now a is 4 and b is 8 and c is 0. Now the first relation is alpha plus beta equals to minus b by a. Alpha is 0 and beta is minus 2, and minus of b is 8 and a is 4. So 0 minus 2 is minus 2, and dividing 8 by 4 we get 2, so that is minus 2. So one relation is verified, and the second relation is alpha into beta equals to c by a. So alpha is 0 and beta is minus 2, c value is 0, a value is 4. So 0 into minus 2 is 0, 0 divided by 4 is 0, so hence both the relations are verified. And question number 5, that is t square minus 15. So this can be factorized. For this we can find the zeros of the polynomial in two ways. One is directly, because there is only one variable and present in only one place, so we can isolate the variable and we can find the values of t. That is one method. The other one is express this in the form of a square minus b square and then factorize it. So let me teach both the methods. So in the first method, let us isolate t square, means let us isolate t, equating this to 0. So first transpose minus 15 to RHS, we get t square equals to plus 15. Now put square root on both sides to remove the square. So square and square root will get cancelled in the LHS, and we get t equals to, now we have root 15. So root 15 is basically can be written as plus or minus root 15. So we can write one 0 as plus root 15 and another 0 as minus root 15. This is one method. The other method is write the given polynomial in the form of a square minus b square. So that is first term is already in the square form, second term is minus 15. So 15 can be written as root 15 the whole square in the form of whole square. So now 15 can be written as root 15 the whole square. Now the factorization of a square minus b square is a plus b into a minus b. So based on this we can factorize this. We get t plus root 15 into t minus root 15. Now we equate each factor to 0, that is t plus root 15 equals to 0. From this we get t equals to minus root 15 by transposing root 15 to RHS. And now second one, t minus root 15 equals to 0, transpose minus root 15 to RHS, we get t equals to plus root 15. So take one as alpha and another as beta. So now we got the zeros of the polynomial. Now let us verify the relation. So alpha is minus root 15 and beta is plus root 15. And now write this in the standard form. The standard form is t square plus 0 times t minus 15. Now a value is 1, b value is 0, c value is minus 15. Now the first relation is alpha plus beta. Alpha plus beta equals to minus b by a. Alpha is minus root 15 and beta is plus root 15. And minus of b value is 0 and a value is 1. So minus root 15 and plus root 15 becomes 0, and RHS also 0 divided by 1 is 0. So first relation is verified. Second relation is alpha into beta equals to c by a. Alpha is minus root 15 and beta is plus root 15, and c value is minus 15 divided by a is 1. Now when you multiply, minus into plus is minus in the LHS, and root 15 into root 15 is 15, equals to minus 15 by 1 is minus 15. So hence verified. And the last question is 3x square minus x minus 4. So here the sum is minus 1. It's already in the standard form. And the product is 3 into minus 4. 3 into minus 4 is minus 12. As I have told you in the previous problem, when the product is negative, one number should be negative and one number should be positive. And look at the sign of the sum. So sum is negative. When the sum is negative, along with one number is negative and one number is positive, we can conclude that greater number should be negative and smaller number should be positive. Then only when we add greater negative number and smaller positive number, we get the sum as negative number. So let us write all the possibilities for minus 12. So for minus 12, taking greater number as negative and smaller number as positive, we can write minus 12 into 1 and minus 6 into 2 and minus 4 into 3. So these are the all possibilities, taking greater number as minus and smaller number as plus. Now each pair will give you minus 12 when you multiply, but which one of this will give you minus 1 when you add them? So adding minus 12 plus 1, we get minus 11, so this won't be satisfied. And minus 6 plus 2, we get minus 4, this also won't be satisfied. And then minus 4 plus 3 will give you minus 1, so this will satisfy both the conditions. So we are supposed to split the middle term using minus 4x and plus 3x. So write the first term, that is 3x square and minus 4 as it is and equate it to 0, and split the middle term as minus 4x and plus 3x. Now group them, and from the first group there is a common factor x. So divide the first term, that is 3x square by x, we get the quotient, that is 3x. So write 3x as the quotient for first term and divide minus 4x by x, we get minus 4 as the quotient. And from the second group there is no common factor, so take 1 as the common factor, plus 1, and we can write the same terms because dividing 3x minus 4 by 1 we get the same quotients. And now we can take 3x minus 4 as the common factor, divide x into 3x minus 4 by 3x minus 4, we get x as the quotient, divide plus 1 into 3x minus 4 by the common factor 3x minus 4, we get plus 1 as the quotient. Now we equate each factor to 0 and then get the zeros of the polynomial. So 3x minus 4 equals to 0, 3x equals to 4 by transposing minus 4 to RHS. Then x is equal to 4 by 3. Then second factor is, so take this as alpha. And now second factor is x plus 1 equals to 0, x equals to minus 1. So beta equals to minus 1. So now we got the zeros. Now let us verify the relation. So alpha is 4 by 3 and beta is minus 1. Now write the coefficients. A is 3 and B is minus 1 and C is minus 4. So the first relation is alpha plus beta is equal to minus b by a. Alpha is 4 by 3 and beta is minus 1, and minus of b value is minus 1 and a value is 3. Now take the LCM of 3 and 1, we get 3. Now first denominator and LCM are same, so first numerator will be written same, and second denominator is 1, so 1 into 3 is 3. Therefore multiply the numerator also by 3, we get minus 1 into 3 is minus 3 equals to minus of minus 1 is plus 1, so we get 1 by 3. So in the LHS 4 minus 3 is 1, so we get 1 by 3 on both sides. One relation is verified. The second relation is alpha into beta equals to C by A. Alpha is 4 by 3 and beta is minus 1 and C value is minus 4, A value is 3. So multiply the LHS, that is 4 by 3 into minus 1, we get minus 4 by 3. In the RHS also we have the same number, minus 4 by 3, hence verified. So both the relations are verified. So children, if you have any doubts from this particular concept or from any other concept from grade 9 and 10 CBSE syllabus or state syllabus, Karnataka state syllabus, you can type the questions in the comment box so that I can make the videos on that. Please subscribe to my channel and click on the bell icon for the to receive the notifications for the new videos. Please subscribe to my channel. Thank you so much.